So hello everyone, my ID number is 20150 and in this video I am going to talk about parallel processing. And these are the topics we are going to cover in this presentation. So an overview of parallel processing, parallelism in uniprocessor systems, organization of multiprocessor, in which we are going to cover Flynn's classification, system topologies and MIMD system architectures. So the first topic is an overview of parallel processing. So what is parallel processing? Parallel processing is a method to improve computer system performance by executing two or more instructions simultaneously. The goals of parallel processing. One goal is to reduce the wall clock time or the amount of real time that you need to wait for a problem to resolve. Another goal is to solve bigger problems that might not fit in the limited memory of a single system. So now parallelism in uniprocessor systems. It is possible to achieve parallelism with a uniprocessor system. Some examples are the instruction pipeline, arithmetic pipeline, and I/O processor. Uh, I/O processor. Note that a system that performs different operations on the uh, note that a system that performs different operations on the same instruction is not considered parallel. Only if the system processes two different instructions simultaneously can it be considered parallel. Parallelism in a uniprocessor system. A reconfigurable arithmetic pipeline is an example of parallelism in a uniprocessor system. Each stage of a reconfigurable arithmetic pipeline has a multiplexer at its input. The multiplexer may pass input data or the data output from the other stages to the stage inputs. The control unit of the CPU sets the select signals of the multiplexer to control the flow of data, thus configuring the pipeline. Vector arithmetic unit. A vector arithmetic unit contains multiple functional units that perform addition, subtraction, and other functions. The control unit routes inputs values to the different functional units to allow the CPU to execute multiple instructions simultaneously. For the operations B plus B plus C transfers A and E minus F transfers into D. The CPU would route B and C to an adder and then route E and F to a subtractor for simultaneous execution. Organization of multiprocessor systems. Flynn's classification. It was proposed by researcher Michael J. Flynn in 1966. It is the most commonly accepted taxonomy of computer organization. In this classification, computers are classified by whether it processes a single instruction at a time or multiple instructions simultaneously and whether it operates on one or multiple data sets. This is the image for SISD tech machine. Single instruction, multiple data. An SIMD machine executes a single instruction on multiple data values simultaneously using many processors. Since there is only one instruction, each processor does not have to fetch and decode each instruction. Instead, a single control unit does the fetch and decoding for all processors. SIMD architectures include array processing. This is the image for SIMD. Multiple instruction, multiple data. MIMD machines are usually referred to as multiprocessors or multicomputers. It may execute multiple instructions simultaneously, contrary to SIMD machines. Each processor must include its own control unit that will assign to the processor's parts of a task or a separate task. It has two subclasses, shared memory and distributed memory. Multiple instructions, single data. This category does not actually exist. This category was included in the taxonomy for the sake of completeness. System topologies. Uh, A system may also be classified by its topology. A topology is the pattern of connections between processors. The cost-performance trade-off determines which topologies to use for a multiprocessor system. Topology classification. A topology is characterized by its diameter, Total bandwidth and bisection bandwidth. A topology is a topology is characterized by its diameter, total bandwidth, and bisection bandwidth. Diameter: the maximum distance between two processors in the computer system. Total bandwidth: the capacity of a communications link multiplied by the number of such links in the system. Bisection bandwidth represents the maximum data transfer that could occur at the bottleneck in the topology. Uniform memory access (UMA). The UMA is a type of symmetric multiprocessor or SMP that has two or more processors that perform symmetric functions. UMA gives all CPUs uniform access to all memory locations in shared memory. They interact with shared memory by some communications mechanism like a single bus or a multi-stage interconnection. Non-uniform memory access (NUMA). NUMA architectures, unlike UMA architectures, do not allow uniform access to all shared memory locations. This architecture still allows all processors to access all shared memory locations, but in a non-uniform way. Each processor can access its local shared memory than the other memory modules, more quickly than the other module, uh, more quickly than the other memory modules. Not next. This is the image for non-uniform memory access architecture. So thank you all for watching. This is it.